To write polynomials and make them easier to read, they are written in what's called descending order of powers, and that means the exponents on the variables are in order from greatest to least. So let's look at 5a cubed plus 7a squared minus 3a plus 11. This is already written in descending order because if we look at the powers, we have a cubed, a squared, and then a, and remember when an exponent is missing, it's a 1. So now the exponents go from biggest 3 to smallest 1. So for example, rewrite the polynomial in descending order of powers. The highest power is x squared. 2 is our biggest exponent, so it has to go first. And remember, the sign in front of a term always moves with it. The next power we have is x, which is x to the 1. And because there's no sign in front of it, we know it's positive. And then the constant goes at the end. X squared minus 3x plus x to the 5th minus 1. X to the 5th is positive in first. X squared is the next biggest, and a 2 it's positive. 3x is the next one, and it's negative. And then the constant goes at the end, negative 1. What about 7 plus x? X is our only power, it's the only variable, x to the first, and then our constant goes at the end, and because it's in front with no sign, we know it's positive. And finally, 125 minus x squared plus x to the first. Negative x squared is our highest power. Positive x to the first is our next one, and we don't need the 1, it can be just x. And 125 is our constant at the end. Representing polynomials. So similar to the algebra tiles that we used for integers, we can now expand the tiles to represent polynomials. So we're going to have the red and blue to be positive 1 and negative 1. And they are length 1 and width 1, so their area is 1 by 1 equal to 1. They are both the same size. But now we're going to start representing variables. So to represent x, we're going to use the longer rectangle. So the length is x, the width is 1, so the area is length times width, or 1 times x gives us x, and red is positive, blue is negative. So now the expression x squared means an area represented on both sides by a distance of x. So the length is x, the width is x, so the area becomes x times x, or x squared. And still, red is positive, blue is negative. With these algebra tiles now, using a couple different sizes, zero principle still remains though. 1 red and 1 blue of the same size cancel out to give 0. Positive 1 subtract 1 is 0. You can also use the x tiles. Positive x subtract x is 0. These will cancel out. And same with the larger squares, the x squareds. A positive x squared and a negative x squared will always cancel out to be 0. So now we can represent polynomials with the tiles. 2x squared minus 3x plus 4. Well, positive 2x squared is 2 of the positive, or the red, x squared tiles. Negative 3x is 3 of the blue x tiles. And positive 4 will be 4 of the red tiles, the 1 by 1 or the 1s. So I have 2 x squareds, 3 negative x's, so negative 3x, and a positive 4. Negative 4x plus 2 minus x squared. Well, negative 4x's is going to be 4 of the blue x tiles. Positive 2 is 2 of the red 1 tiles. And negative x squared is a blue x squared tiles. Negative 4x's, positive 2, and a negative x squared.